Last last month we talked about kind of how mobile's changing the business and enterprise in general. Today we're talking about, well, how do we secure a lot of that? And so we've got Scott Behrens and John Janego from NeoHapsis, and you guys are out of Chicago, right?
Correct.
So they will be talking through. They're both senior consultants there and have lots and lots and lots of technical security background. I think we're going to try to keep it not extremely technical, but if you got technical questions, these guys should be able to answer them. So we'll go through it. Feel free to, if you got questions, just raise your hand. I'll try to get a wireless mic. We'll pass it around to the people on the phone. And at Appleton, were we ever able to get Appleton to join us?
Yeah, we're online.
Okay, great. All right, we got everybody. So I'll turn it over to you guys.
Test 1, 2, okay. Good afternoon, everybody. Can everybody hear me okay? Great, excellent. So my name's Scott Behrens, and this is John Janego, and do you want to control?
Sure.
Thanks. And we're going to present some research we've been pulling together on mastering the mobile security landscape. Sorry. Go ahead. So John and I both work for NeoHapsis. We've been there, both of us actually kind of started around the same time for about 2.5 years. And we're a security consultancy that's been around since 1997, and we're strongly focused on application and mobile security, as well as cloud security initiatives. We have a big risk and GRC side of our business too, but John and I actually come more on the technical side, focused around application and mobile security. I'm a senior security consultant with NeoHapsis. I'm also an adjunct professor at DePaul University. I teach courses on software security engineering. And I primarily do all my work around application and security research.
And I'm a senior consultant. Also, I kind of do a little bit of everything at Neo, but lately I've been doing a lot of application security. But I've also worked on risk management projects, vulnerability management projects, security operations, a little bit of everything. So what we're going to talk about today, and we may have a little bit of a rehash from the last month's meeting, but we're going to talk about the history and significance of mobile in enterprise today. Cover sort of a little bit more on the technical side about how a mobile device actually works, then cover some of the security concerns and how to use mobile devices securely in enterprise. Then talk about what mobile applications actually are, how they work, and cover the different platforms about how they work, and then cover mobile application security, and then kind of wrap it all up. So, mobile devices, as you know, these days are everywhere. They've been everywhere for a good couple decades now, but the last 10 years in particular has had a big growth in the mobile space. We're not going to talk about the whole history of mobile devices, but we do want to talk about some of the more recent history. So in the last decade or so, we've seen a big change from what's considered sort of the smartphone space. Back around, say, 2000, 2001, was what was called the feature phone. It's sort of a basic model smartphone, especially compared to what things are today. They have relatively limited functionality. They had some had internet, but it was really slow, so we didn't have sort of the high volume data applications. Some had cameras, but they weren't very good. The primary risks that they faced, that businesses faced, were sort of more around device misuse, sort of, people using their phones to, call internationally. Not so much the data security concerns that we see today, just because they were relatively limited feature-wise. Compared to the old feature phone, today we have a big difference in what the phones are today. Phones today have always-on broadband connections. They have 8 gigs of RAM, super high-resolution cameras. Linux-based OSs that are built for flexibility and extensibility. They have, everybody who's ever developed a Java application or a Linux application or a Windows application can pretty easily, develop a mobile application, which has led to an increase in functionality. And coupling that with, always-on internet connections, it's created an environment in which you have mobiles essentially equivalent to desktops in terms of how often they're being used and the amount of things you can do with them. And another thing is, especially in the last 5 to 6 years, since the introduction of the iPhone in particular, but even before that, the BlackBerry, people were making crackberry jokes, but people have now become quite addicted to their smartphones and expect to be using them a lot. People, just for speaking for myself, I know I use my smartphone a lot more than I use my desktop for, especially at home. And people have also become rather tech savvy with their phones.
And we were kind of mentioning earlier just the idea of when you walk into a subway station or you sit on a train, if you look around, you'll notice at least half the people at any point in time are interacting with their phones, whether that's to check email, to play games, or to do social media activities.
And this has a lot of implications for human interaction in general, which is far outside of the scope of our talk today. But it just goes to show the increasing reliance on mobile devices in today's world, and sort of, they're becoming our external brains to some extent. So here's some data that backs that up. I do have a laser pointer, but way back down there is 1985. You see barely any mobile devices. I think that's something like 200,000. And now, as of June 2012, there were more mobile devices with active subscriptions than there are human beings in the United States. So I don't know quite exactly why that is. Maybe people have like their old AOL accounts. They've forgotten to unsubscribe from their mobile phone providers. But we definitely reached a saturation point where almost all of the United States population has a mobile phone. And not on this slide, but an interesting statistic that we found while doing some research for this is that over 50% of these mobile subscribers are smartphone users. This is some data starting in 2009 showing the total data traffic, and we've seen a 600% increase in data traffic just in the last 4 years. This, again, as the number of smartphone users continues to increase, and especially as the technology that, with wireless broadband is increasing, we're going to see this number continue to go up. So, and especially the fact that these broadband devices now, like with LTE, has sort of the same bandwidth that you can get at your home. We're seeing a lot of people switching over to this and just never looking back, basically. So, we don't need to go into this too much because I think it's sort of self-evident, but mobile devices do provide a great advantage to businesses. They enable workers to work remotely, to not have to go to the office all the time, to be on call more often. They have a lot of productivity benefits. I can, access SharePoint from my phone and get files that would otherwise be inaccessible if I'm at a customer site or something. They also represent a unique opportunity for businesses to engage with their customers. Now businesses have essentially a direct line into their consumers' pockets, allowing them to bypass TV and other traditional forms of advertising and to interact with them directly. This also has a particular relevance for retailers because people can now purchase things on their mobile phones, and the retail numbers from the holiday season of 2012 demonstrate that a lot of people are doing a lot of shopping on their phones, and we've actually seen some interesting statistics saying that prices are different on your mobile phone versus they are on the desktop site, and it's just a really interesting place to be these days. And because of this allure, both for what the enterprise users are benefiting from and the interaction with consumers, everybody is starting to move everything to mobile. So there's a great demand from both the enterprise side as well as from the reaching out to your customer side. And as I said before, people are now expecting to be able to use their mobile devices for almost everything they can use their PCs for. And in some cases, you can use your mobile devices for things that you can't use your PC for, like I don't have a GPS in my laptop. I don't have a camera that can instantly upload my photos to Dropbox, and like I have on my mobile device. So in some places, they're better than the PCs are.
So we're gonna drill into just the top two mobile device platforms, Android and iOS. Worth mentioning is Windows 8. We're seeing that slowly kind of penetrating into the market, although I think the adoption rates are going to be significantly slower. It was pretty much parallels with when Windows 7, mobile Windows 7 was launched. We kind of saw some organizations adopt it in, but in general, we're seeing a lot of enterprises focusing and centering their efforts around Android and iOS. Honorable mention is BlackBerry. I mean, they've been a player for a while, but I think they're kind of falling to some of the larger players right now, like Android and iOS, and then Symbian. It's worth mentioning. So let's do the platform breakdown. So this is kind of an interesting slide. John and I had a little bit of trouble kind of pulling together the statistics. There's wide varying amount of data on actually where the smartphone market share is. We looked at Gartner and a couple other things, and we kind of just coalesced all this information together into this one slide. And I think this gives pretty much a snapshot of 2012, but we'd imagine this to probably shift dramatically in 2013 as Android continues to make improvements and we see maybe another release of iOS or updates to that platform. So we see that Android roughly has about 68% of the market share, with iOS falling right around 17%. So just those two platforms alone, take well over, or right around 75%, or actually 80, a little bit over 80% of the market share. And I don't really, I think John and I both agree that we don't really see this changing too much, at least over in the short term, just based on the fact that these are really well vetted, well developed, and well supported smartphone platforms. So.
And this slide only covers smartphones as well. It doesn't cover tablets. So when thinking about enterprise, tablets especially are something that a lot of businesses are starting to use. And that would probably skew the numbers a little bit more in favor of iOS here, since the iPad is sort of the gold standard tablets. Although, again, the Surface is making some inroads, and Android tablets are starting to pick up. But everyone still thinks iPad when they think tablet.
Right. So to kind of touch on Apple's flagship OS, we're going to discuss a little bit about what iOS is. So this was introduced in 2007 by Apple and pretty much changed the game for smartphones and their adoption rate with enterprises and end users. It's derived from Apple's flagship OS X operating system, and it's built on a highly customized Unix variant that Apple's been working on for quite some time. The applications that run in OS X are written with the Cocoa framework, and they're coded in Objective-C. And this, we'll see, is a little different than how Android works. So first device was released in 2008 or 2007. This is a little bit of gray area here, but we will stick with 2008 for the slides. It's also running a custom Linux kernel, a little bit different than Apple, who's running a BSD variant. Here we're seeing a variant on the Linux kernel. In Android software, the middleware is written in C, but the applications that run on Android software are written in Java using the Android Software Development Kit. So should we be concerned from this stuff from a security perspective? I'm sure everybody here in the audience is concerned from this from a security perspective, but a 2012 WebRoot survey found 83% of organizations polled for this survey believe that mobile devices create a high security risk. And I don't think that that's any surprise. We can see this being a pretty big concern for us and a big challenge as we move forward with mobile. 73% of businesses have a mix of company and employee-owned devices. So this presents kind of another unique challenge. If we consider, maybe I start I get hired at a new company and I start a new job. And on the first day, they issue me a company laptop, and that has its own sets of rules, policies in place, restrictions for me to install software. We have companies, 73%, that not only have that company-issued phone, but I also have my phone, which contains, games, social media stuff. And so we're kind of running this issue where, in the past, we don't really, a lot of organizations wouldn't let, a company just come in and take your laptop at home that's running your uTorrent software and all your games and plug it into the network. And now we're running into a situation where that's actually happening. That presents a really unique set of security challenges that we have to face. In addition, 47% of the companies polled for this survey had implemented some sort of mobile security solution. So we are seeing more organizations, trying to tackle this problem through a variety of different, controls that we're going to kind of discuss today. And obviously, one of the biggest challenges that we're running into is the rate of mobile adoption. We're kind of in this pace where things are happening so fast that the security challenges that we're running into, we don't necessarily have, really well vetted solutions for. So we're kind of playing this rat race game where we're one step behind, the attackers that are focusing their efforts on mobile security. So we're in a kind of a really interesting challenge here because, we're kind of not in first place.
So now we're going to talk a little bit about mobile enterprise security and how some of the threats exist with regards to mobile in enterprises and how to mitigate some of them. So the first thing I want to start talking about is sort of baselining and think about what the overall mobile threat landscape is. A lot of the risks around mobile in particular come down to the risks related to data loss and leakage. So this could either be the classic scenario of you lose your phone and somebody gets access to your company email and you never know that the phone was lost. to something more severe like intellectual property loss. So again, you have a phone that maybe, like I mentioned before, has access to the SharePoint site, and now they can get access to, say, company patents or negotiation or financial records, that kind of thing. Employee privacy is another concern. Employees who are using mobile devices, especially those issued to them by their employers, have some baseline expectations around privacy, and the employer arguably has a responsibility to protect their employees as well. But mobile applications could potentially present some privacy risks. We've seen applications in the past that are actively updating the location information about where everybody who's using the application is. So the developer of the application could have a database of people's usage, siphoning off people's contact books, photos, other malicious things like that, and even more benign things that may not inherently be bad, but could still represent a privacy risk, or at least a breach of trust. There's still the issue of mobile usage fraud that I mentioned before with regards to the feature phones, but with mobile, now we have the other vector of you can have an application that is silently sending text messages to a 900 number, and the malicious person who installed the software owns that 900 number, and they're getting revenue from every time a text message is sent. This may sound like a weird scenario, but it's actually something that happens. Making phone calls to international numbers and racking up usage charges for the end users as well. These are all examples of things that malicious applications could do, and just are sort of a snippet of some of the risks. Scott's going to talk a little bit more about some of the more specific application attacks. But when thinking about making mobile a critical part of your enterprise, you have to think about sort of some of the overall potential risks that are out there, and these are some of that exist. In addition to these, we have operating system and wireless technology vulnerabilities. These are things that are not necessarily always in control, that you can't really do a lot about, but the fact that both OS X and that both iOS and Android are based on Linux and Unix kernels, respectively, greatly increases the attack surface there, because a Linux kernel issue that is present on Linux desktops also could be present on Android phones. And same thing with BSD issues that are present on BSD desktops and servers could also be present on iOS. Obviously, Linux kernel exploits and BSD exploits are not something that you see every day, but it's an attack surface that our attackers are aware of, and there's decades of research that exists about them. And that does present another risk to the enterprise. And oftentimes, especially in the Android ecosystem, but to iOS to some extent, the enterprise is limited to how much they can actually do to protect or to prevent what versions are running on the devices as well. There's also wireless technology vulnerabilities. By their very nature, mobile devices are wireless. They use everything from cellular technologies like GSM and CDMA to 802.11 wireless, Bluetooth, NFC, and other emerging things. I wouldn't be surprised if we're starting to see more smart meter type technologies like Zigbee being implemented within mobile devices going forward as well. So all the potential wireless threat landscape that's out there, and there is a large landscape of opportunities for attackers there, also is something present on mobile devices. And again, there's not a lot you can do about it necessarily. There are some controls that we're going to talk about a little bit later, but it's just another part of the threat landscape. And when talking about any security decision, you must first be informed about what you actually need to be worried about. Yeah. Rooting is another potential issue that we're going to talk a little bit more about with regards to application security. But essentially, rooting a device is something that negates a lot of the security controls that we implicitly expect in it. And we're going to go into that a little bit more. So when approaching mobile security in the enterprise, I like to think about this sort of as just a normal security engineering problem. You want to both layer your approaches to defense and think about it from a couple different perspectives. I like to think about it from the perspective of, first off, secure your infrastructure and the rest of your business from the mobile devices, assuming that they could either be compromised at any given moment. And then also secure the mobile devices themselves. So even assuming they are compromised, mitigating or minimizing the risk that you can expect to see from a device that's been compromised. So here's a sort of nice little visual about how you can layer your enterprise security controls. This isn't terribly different from an overall just how you would layer security controls in general, but with regards to mobile, I have a few specific technologies mentioned here. So first off is policy, which should govern everything. We'll talk about that a little bit later. And then you want to harden your infrastructure and then harden your desktops as part of your infrastructure. And then you can use technology called mobile device management to harden the mobile devices themselves and minimize some of the issues that you could find in the context of a compromised mobile device. So, talking about mobile security policies. Well, first off, we are open to asking questions. If you guys have any right now, feel free to interrupt us. We want this to be a semi-interactive session, so please feel free to interrupt if you have any questions or comments while we're going. But okay, so policies. So like all security implementations within an enterprise, having a clearly articulated set of policies in your business is sort of the most fundamental and important step. You can't control what users do, but by having articulated policies saying what users are allowed to do goes a long way, because ultimately when you're thinking about an enterprise, you're thinking about employees, and employees usually want to continue to be employed. So if they're violating policies knowingly that could present some, they have a reason not to do it if they know they could get fired as a result of violating the policies. So clearly articulating what the acceptable use of mobile devices is. Again, like I mentioned before, because people have such attachments to their mobile devices, people forget that their work phone is their work phone. It's not their personal phone. So people could do benign things like texting, their wife when they're leaving work. I mean, that's not really a business risk, but if you're installing pirated applications on your phone and who knows what's in them, or you're doing illegal activities using your phone, that's sort of crossing the line, and an employee may not think about that because they're just sort of conditioned to the fact that, oh, it's my smartphone, I just use it for whatever. It's just an extension of my body. Like all policies and governance things, there's only so far that you can go, but regular employee training and reminders, talking about these in yearly reviews and that kind of thing with employees is a good place to start. And again, you just want to make sure that your employees understand that these are business devices. It's a privilege, not a right necessarily, to be using your mobile device, and that there are consequences for using it, and also some strings attached. Some of the common policies that we've seen with mobile device usage is, if an employee is using company data on their mobile device, the device can be wiped remotely by an administrator at any given moment. Not saying that it's going to happen or even will happen, but as we're going to talk about a little bit later, and that's one of the specific controls that exists in this mobile world is the ability to remote wipe. And it's a way that business can minimize risk, and a way that the users can understand that, hey, this is somebody else's device, not mine necessarily. So moving on to the concept of hardening your infrastructure. So when thinking about mobile devices, in particular in terms of how you use them within your enterprise itself, a lot of the times your employees using your mobile device are either going to be using it on a wireless LAN inside your building, or they're going to be using a mobile data network outside of their building. And one of the things I want to emphasize when thinking about especially the wireless LAN is to drop your clicker. is to first off use the best practices for wireless LAN security whenever implementing a LAN that's going to be specific for your employees' mobile devices, and also implement a wireless LAN specific for your employees' mobile devices. A lot of times, and I've worked with a lot of clients about wireless LAN design especially, and people think, oh, I'm just going to implement a wireless LAN, it's a wireless LAN. It doesn't matter where it terminates. I want my guests to have internet, and they want that, so I'm just going to plug it in, and don't think about sort of how they design it. But you should still apply good sound security engineering principles when designing a wireless LAN, especially something for guests and for mobile users that is in a potentially untrusted state. I would recommend segmenting it and only allowing access to specific things that the mobile devices are allowed to have access to. So if my mobile device is inside the wireless LAN and I only want it to be used for email, but I want my employees to be able to use wireless LAN for improved speed or battery life or whatever, only let it hit the email server. Don't let it just have unfettered access to everything on the internal corporate network. And again, think about segmentation of the networks, and particularly when it comes into mobile applications, which we're going to talk about again later. Whatever your mobile applications are going to be accessing, make sure that your endpoint listeners are segmented off from everything else. I don't want necessarily, because I have a mobile application, that I can access every piece of infrastructure within the environment. When it comes to mobile data networks, ultimately you have to treat them like an ISP, as unfortunate as that may be. There's not a lot of control that you can do against the data network that you're getting provided by a mobile provider. Obviously, you can have contracts and that sort of thing in place.
Essentially VPN access.
Yeah, using mobile device management, you can enforce things like forcing people to use VPNs, which is fantastic. But ultimately, you got to treat it as an internet connection. It's a dumb internet connection. It provides a lot. It probably exposes a lot less risk than you see something at a hotel or whatever, because it's in the best interests of Verizon and T-Mobile and whatever to have strong protections around their data networks. But again, it's just something you have to be aware of when thinking about how to approach the risk modeling and threat modeling with wireless devices. So mobile devices and desktops. Another thing that kind of gets overlooked sometimes about mobile devices is that my mobile device that I have here has a 32 gigabyte storage capacity with it, and it gets mounted as a USB drive whenever I plug it into my PC. So it's not only a phone, it's a portable USB drive. So I could have the strongest mobile security controls around, but the fact is, when I plug it into my desktop, unless I've hardened my desktop to allow me to not access USB drives, I can take whatever else I want on my phone and no one will notice. Users can also access the underlying mobile device file system using their desktops. You may think, oh, my Android device doesn't have a browser where I can look at all the files on the phone, but if I mount it on my laptop, I can, or the iOS device is the same way. Within the enterprise, you can also implement data loss protection, DLP solutions. That's a whole different can of worms, really, but they are effective at protecting against these type of things. And you can also enable best practices for iTunes security. You could have iTunes completely disallowed within the enterprise, or there are some other security controls you can implement with.
Yeah, iTunes actually has a very granular permission model, and you can kind of specify, I don't want some of the Genius and some of the features that actually do internet-y things. You can disable that. You can disable the type of information that you can actually sync to your phone. So one of the things I was looking at this year was actually based around iTunes security, and I was trying to think about ways to kind of get sensitive information through iTunes with only being able to sync photos or something like that. And so what I was doing is I was just taking binaries and putting them in the footer of image files and syncing them to my phone, getting home, and then pulling off the binaries. So there are ways to circumvent some of these controls, but something like data loss prevention, hopefully, would have actually caught me copying.
Potentially. Yeah.
Would have looked at those files that I was copying and actually realized, well, they're not really images, they're actually binaries. And so, once again, it's best to have an approach that encompasses many of these security technologies, so that when an attacker tries to circumvent one of the controls, another control will mitigate that circumvention.
Exactly. And so it goes to show that mobile devices they don't just stand on their own. If an employee is using them in the office, they can take files off of machines or off of servers even, I suppose. So mobile antivirus as it stands right now is not the solution to all of these problems either. So some vendors are starting to try and advertise antivirus for mobile. As it stands today, this is not necessarily the most effective, certainly not as effective as antivirus is on desktops, for a couple of reasons. It's been a subject of debate in the mobile community. In fact, there was a pretty controversial post by one of the Android developers that he made about a year ago
Calling antivirus companies charlatans and scammers. So
Yeah, and I wouldn't go that far, but I would say that they're right now, as they stand, they're of questionable effectiveness in terms of protecting against viruses in particular. Some of the features of the mobile antivirus platforms have a lot of cool features, like Lookout in particular has like tracking. You can do remote wipe, but they're all focused more on consumers rather than on enterprises. You know, when you're thinking antivirus, especially in the enterprise context, you're thinking like a SEP 11 or something like that, where you have like a huge console and you can do all this auditing and a lot of granular control, but that doesn't really exist in the mobile antivirus space. But a technology similar to that does exist, and it's not exactly called mobile antivirus. It instead is called mobile device management. So mobile device management, at a very high level, what it is it's a suite of software that allows administrators, remote management and provisioning of mobile devices. Both iOS, Android, BlackBerry, Windows, I don't know about Symbian, but at least those four all have API hooks exposed. And if you're not familiar with what APIs are, they are interfaces that allow developers to write software that controls management functions on the device. So what the mobile device management platforms have done is take advantage of these features that are built into iOS and Android and write an entire suite of tools that allows for remote management of devices. They range from relatively basic controls to extremely comprehensive ones, and you can choose sort of how you implement them. A lot of the bigger ones these days are now cloud-based ones, which takes advantage of the fact that their data that you have always on data connections, but you can also have like an appliance mounted one similar to how you do a lot of other enterprise technologies. So yeah, all of these have MDM features built in. Apple, interestingly enough, is sort of pulling ahead of Android in the feature availability. This is for a couple of reasons. I mean, could be both business strategy-wise as well as the fact that they have a much tighter control on their overall operating system ecosystem. And they're also winning the tablet market, which is also, as I said, is an increasingly big market in the enterprise, so there's increasing demand for it. But BlackBerry is still like the gold standard of all of these with regards to mobile device management. BlackBerry has over 500 API controls that you can use to control almost every single feature on the phone. Whereas I think Android 4.0 introduced 16. iOS has a similar number, but I mean nothing compared to 500 in BlackBerry. But the trouble with BlackBerry is they are getting pounded pretty well in the market and increasingly seem to be a little bit losing their focus on where they're going. But interestingly enough, Apple is focusing on this, and rightly so, I say. So most mobile devices, even if you're not using the full MDM suite of tools available, if you're using email, you have a basic form of mobile device management already implemented on your phone. The Exchange administrator, if they've enabled it, can do enforcement of basic security policies like this. Screen lock, enforcing having a PIN. They can enforce mobile device encryption, and they can do remote data wipe, although I believe it's limited only to the email data, although I'm not 100% sure about that. But that's only a very basic form. Exchange that's not sort of the main focus, and Microsoft hasn't made it an incredibly, they haven't made it a business focus like some of these other vendors have that focus entirely on it. Some of the more interesting operational features that you can have when you have a fully implemented mobile device management solution is you can have detailed reporting on users and devices. So reporting on almost everything, tracking of location, tracking of the amount of data being used, what the phones are being used for, that sort of thing. You can restrict and monitor phone usage, saying, so when I mentioned when you have to consider mobile device, the data connections that your mobile device are using, I could say, well, I only trust Verizon, so I'm going to only accept Verizon mobile devices onto my network, even if someone tries to provision an AT&T one. They can detect rooted or jailbroken devices, and in some cases, which is kind of funny from a sysadmin perspective. If they detect a rooted one, they'll immediately wipe the phone back to the stock state. Perform remote wipe of lost devices. Some have this concept of personal space and workspace on users' phones where, after 5 p.m. the phone becomes personal time. They have a whole their suite of applications available to them that they're completely segmented away. Other features here, you can enforce password and PIN complexity, a whole suite of application management features, such as whitelisting and blacklisting applications. Interestingly enough, you can block specific application permissions, but still allow the applications themselves to run. No guarantee that it's not going to completely crash the application when you do that, but you can block specific permissions. If, for instance, you want to block applications from having fine-grained GPS access, you could do that. It may crash Facebook, but oh well. And you can also do remote removing of applications and data, as well as some even more complicated application management features. And we can, neither of us work for an MDM vendor. We're just kind of here to give you an overview of what the technology can do, but you can do a ton of stuff. And this is a huge market that's growing, and it's a really interesting place to be paying attention to. They can also encrypt data storage on the phone, even if the phone doesn't have native encryption. So newer model iPhones and newer model Android devices have essentially disk encryption on the devices. What these mobile device management solutions can do is do sort of more like a TrueCrypt thing where they're storing the data in a big encrypted blob and only decrypting data as they need it. So you're adding encryption on top of a device that doesn't natively have encryption.
And we're actually seeing a similar kind of approach being to applications that are using MDM to roll out their own in-house application stores. So maybe they develop a suite of 4 or 5 applications they want their employees to run, and those are maintained with the MDM solution. And maybe that also includes hosting a couple of other apps like Twitter or something like that. What we're actually seeing with some of the more advanced MDM solutions is the ability to encrypt application data stores and actually do some basic hardening of some of the calls with those applications. So we're actually seeing a pretty severe or pretty intimate level of sophistication with MDM solutions, potentially allowing you to host an application that might expose a lot of risks, but actually allow MDM to make changes to the way that application acts and stores data that'll make the application more secure, which is really interesting.
Yeah, so like decompiling third-party applications and recompiling them to a more secure format that you approve.
Pretty neat.
Yeah. So yeah, that's sort of the future of mobile device management. They're increasing to focus on tablets. Expansion into desktop management, which is another interesting thing. The solution that Scott was just talking about is something that we're familiar with called Nucona. They were recently purchased by Symantec. Symantec already has a desktop management solution. I wouldn't be surprised if in the next few years you're going to see some sort of giant Symantec console that covers your mobile device management, your desktop management, your antivirus, your log software, that kind of thing. Document management is another one. This is another, I'm sure everyone here is familiar with Dropbox and other concepts of remote data syncing. Mobile device management solutions are also going into not just the security features, but these sort of operational features where I can have like a private Dropbox that I'm using between all of my mobile devices, and I know that it's in a trusted environment only. And then as Scott said, the private application stores. All these are pretty interesting. It's like I said before, it's a really interesting space, and there's a lot of vendors in it. This number of vendors is probably going to shrink just as the normal enterprise vendor contraction and consolidation goes. But these are some of the big ones these days. A lot of these, like I mentioned earlier, have both on-site and cloud-hosted solutions. Both have pluses and minuses. We're not a vendor. We're not Gartner. So we're not here to say which one's best, but I will say all of these are from the top box of the Gartner Magic Quadrant. So if that's something that's important to you, these are 7 to write down. So MDM shortcomings. This kind of goes to security in general. So you can't stop a thief necessarily from doing anything. So if I have a truly malicious user who really wants to use his cell phone to steal data, they're going to figure out a way. Whether I restrict access to what you can do on your device with an MDM or not, they're going to find a way to do it with iTunes. They're going to take pictures. They're going to scan it and fax it to their grandma's house or whatever. But when it comes to MDM in particular, I can simply remove the MDM solution from the device. This will send a big flag to the admin saying this user just removed MDM. In some of these solutions, you can actually have it wipe the phone as soon as MDM is uninstalled. That's a little bit draconian, but it is an option. Users, like I said, can work within the restrictions of the MDM. Administrators can lock these phones down so you can't do anything with them, but you'll probably have to deal with some pretty hostile users if you do that. So you'll probably be able to figure out a way if you really want to steal something. But ultimately, like I said, it becomes a policy and enforcement issue. And the other thing, and this kind of goes back to what I mentioned before about antivirus, is these still don't provide protection against malicious applications. Even though you can whitelist and blacklist applications, unless you have like a super small whitelist of like 6 or 7 applications and don't allow users to do anything other than that, there's still always going to be the potential for malicious applications out there. And again, that's just part of the ecosystem. You are mitigating your risk somewhat by having the ability to remote wipe devices, being able to monitor what your devices are doing. So it does provide you a far more insight into it than you would if you didn't have it. But still, you have to take the good with the bad, I suppose. So moving on to mobile application security. But before we go there, do you guys have any questions about enterprise before we move on and focus on application security? And also take questions at the end. Yeah, sure.
Regarding the remote wipe, is it a regular wipe or is it bit by bit wipe?
It's a data wipe. I mean, it's so.
Yeah. I don't know what specific technology. Oh,
Yeah.
sorry.
Yeah,
To repeat the question for those remote,
Sure.
it was the question was, is it just a regular deletion or is it like a bit by bit zeroing things out?
So I don't know if like it's a DoD like issued wipe, like if it's a 3-pass or anything like that. I'd be surprised. My guess is that it would just be a standard, remove the data. We'll have to look into it. There's a possibility that maybe some of the MDM solutions, depending on maybe the application, do the DoD standard 3-pass or something like that, but I'm not actually sure.
So I think a lot of the demand for these type of features is coming from the government. So I may contradict Scott a little bit by saying the DoD standard wipes may be available, but again, we don't know enough about them specifically to say. I'd be surprised though if it wasn't available with at least one of the types, with one of the technologies, just because the U.S. government has such a demand for mobile devices these days. All the vendors are accommodating to those demands. So.
So how are the solutions dealing with as employees move like across international boundaries? I mean, I know there's always been a concern even with U.S. customs, laptop, surge through it, and that's one reason why encryption and locking things down, making sure China, Russia, or something like that.
See, and so we actually
to repeat the question was how are companies, this is again for the benefit of those remote, how do these solutions protect against moving the devices internationally?
And so I don't know if MDM is a great solution for that. What we've been seeing, at least, we've had some of our consultants have actually done some work in China last year, and kind of our best recommendations and practices from kind of looking at the threats of going over into traveling internationally is actually just to bring a completely fresh slate wiped device, and with the intention of knowing that when you get there that your device could be unlocked, that you could be required to decrypt the information on your device and share what that is.
Some of the solutions,
to give a little bit of context on what had happened with Pat, so a coworker of ours, Pat, when he was in China, was SSHing back into, so he's connecting back into a Linux terminal here in Chicago. On the 4th or 5th day he was there, he got a certificate error, and he viewed a certificate and he was getting man-in-the-middle from China. So it only took just a few days before they were in the process of trying to intercept his communication to determine what it was doing. So if he would have accepted that certificate error, his traffic would have been available in the clear text, and they would have been able to see what he was doing back here in Chicago.
Some of the MDM solutions do allow you to gate where your users can operate, though. So I don't know exactly how they work if you were to swap out your SIM, for instance, if I went to Europe. I assume that if it had a data connection, it'd be able to talk back, but and your remote administrator would know that you were there. But again, I'm not 100% about it, but I know that you can. AirWatch in particular is one that I know that you can say I can only operate in Wisconsin, for instance. As weird as that would be, it could say, well, I know my employees are only going to work in this region, and they can't take it
kind of
elsewhere.
called geofencing, right?
Yeah.
Where you kind of have a geo region that you're allowed to perform work in, and then when you step out that region, certain controls come in play, whether that's wiping your device or maybe limiting certain functionality.
There actually are some more sophisticated MDM, and this is going a little bit beyond the realm of MDM and into more different technologies, but there are solutions that will essentially like black out phone usage in certain environments as well. That's something that you see more in like DoD and like Department of Energy places where you're on super sensitive facilities, but it's moved more from just, there's now a technology solution to those type of problems rather than just give your phone to the guard as it used to be. Right. Although it still is give your phone to the guard, but they do both. Any other questions right now? Okay. Do you want me to click still?
No. Okay. All right, so now we're going to touch on mobile application security, which is something I'm very comfortable with and been doing quite a bit of research in now for a few years. So first, we need to discuss what a mobile application is, right? It's an application that runs on a mobile device. You know, it's pretty straightforward. Typically, these mobile applications have some sort of a local data store database or a cache of information. And they often act as a front end with a back end service. Now, this is the majority of the applications that we see in an enterprise space. Keep in mind, there are applications like games that maybe don't interact with a back end service, or there might be applications that don't have a local database or a cache. Maybe maybe they just don't have a need for that kind of design decision. But in general, this is kind of the overall structure of mobile applications, and we'll kind of look at how this parallels a traditional web application. So let's step through how a traditional web application looks, right? So we have our web browser, and I'm making a request to my company's internal ERP software, okay? So I open my browser, and I type in the domain of the web application I want to get access to. The web server receives that request. A module handler based on a file extension or framework. So this could be, the module handler says, oh, I see that you're requesting a resource that is PHP, or you're requesting a framework like Rails that runs on top of Ruby, right? Those are two software languages. It says, okay, now that I know that you're PHP, I'm going to call PHP, and we're going to go ahead and dynamically execute that code. And maybe that code's going to do something like interact with a backend database, pull some sort of resource, and then return that result to your web browser. So how does this look in comparison to a mobile application? Well, it's a little different. We have a mobile application. However, that mobile application is probably going to talk to a web server, which is going to talk to a module handler, which is going to talk to a web application platform and a backend database. So we see that it's pretty much the same thing, with the exception that the mobile application is running in a different kind of trust area, and the mobile application has some other nuances and features that are a little bit different than your standard web browser like Firefox or Chrome. But in general, if we look at the chain of communication between the mobile application and the services we're connecting to, it's very similar. And oftentimes we see this done over HTTP or HTTPS. Occasionally we'll see applications that maybe don't interact with the web server, but interact with a different kind of network service. But in general, this is what we're actually coming across in enterprise. So let's take a look at the mobile threat landscape with regards to applications. And the first and foremost one, and the one that none of us hope to see within our own enterprises is, we're on the cover of Information Week. We get that email in the morning around 9 a.m. and we see 75,000 credit card numbers stolen from a mobile application that was, for company XYZ. This is happening frequently, where we're seeing businesses completely getting destroyed by web application attacks, mobile application attacks, and that inadvertently affects customer satisfaction and customer trust, right? I'm less likely to install an application if I just open up CNN.com and realize, 75,000 credit card numbers are stolen. I might not actually want to install that application, which could lead to something like a financial loss, right? Where now your customers aren't trusting in your applications and what you're doing with it. In addition to financial loss, an attacker might take your application, potentially attack your application or attack your back-end services, maybe disrupt your business's ability to run services, maybe find injection vulnerabilities and steal information from your business. And all these things can tie back to financial loss. So, I mean, there's a serious threat here. And that also puts you in liability. What if your application, your developers inadvertently were leaking information out? So what if my application was leaking my geolocation somewhere to a third party, and a consumer advocacy group realized, hey, your mobile application is telling everybody where you're at, and you get sued. So there's this potential possibility for liability with regards to your applications as well. And then we run into compliance and regulation requirements, and this is things like, if you're using an application that interacts with credit card information, you're going to be regulated through PCI, and you have to follow the rules and regulations with that. So that's another thing to take into consideration. And then we have things like sensitive information disclosure. Maybe I install your Android application, but I figure out a way to disassemble and decompile your application, and now I gain access to your source code. Is there any intellectual property in that source code? And then this ties into key management. Are there sensitive keys in your source code, or passwords, or things that I could potentially use to gain further access into your network and cause issues to your business reputation, your customer satisfaction, your financial loss, right? So it's kind of this triage of areas of threat.
We actually saw this happen recently. I can't remember who specifically it was, and that's probably for the best because I don't want to call anybody out in public, but some application actually did have their private key stored inside the data store, and a security researcher found that private key was stored inside the data store on the mobile device, which was used for code signing of other applications.
So it was able to sign applications as that company, and those applications were malicious. So it resulted in a pretty serious security flaw and whatnot. So
it's a big black eye.
Yeah. So we're first going to touch on mobile application security features in Android. And one of the things that John and I were kind of talking about on the drive up here was that it's interesting that we run into a lot of these parallel risks on desktops because I think by design, we've noticed that a lot of mobile application platforms are a little bit more secure by default. When we go and purchase a laptop from Dell.com and we ship it and we get it in the mail and you open it up, you're administrator right away. You can install apps, you can do whatever you want on it. When we go to T-Mobile, we purchase a phone, we're users. We're not administrators, right, oftentimes. And there's the applications that we have are sandboxed and some other security features, but by design, it's a little bit tighter of a control area. And so that's kind of an interesting observation. One of the main features that really sets mobile devices apart from operating systems is the idea of sandboxing. And what we kind of mean by sandboxing is the idea that every application lives in its own kind of world, right? It has its own set of permissions. It can access stuff within its own sandbox, but it really can't interact with other applications. It can, and we'll talk about how that works, but the general concept is this stuff's isolated. If I run into a problem with my application, if there's an exploit or some sort of security issue, you hope that the attacker would only be able to access what is inside that sandbox, therefore protecting other applications and other data on your phone. That's not always the case depending on how the exploit works, but we'll get into that a little bit later. Android also provides a software development kit that includes common security features you'd expect to find in most well-developed web or coding applications. So things like cryptography functionality and secure inter-process communications. And what IPC really allows us to do is, when we're talking about sandboxing and our applications kind of being in silos, IPC is that mechanism that allows the applications to talk to each other. So one example of an inter-process communication would be I install an application that asks for permission to see my contacts. So anytime that my application now makes a request to see my contacts, that's done through a secure inter-process communication call. And the idea is that you limit the amount of those IPC calls as much as you possibly can, therefore to prevent the applications from being able to do all these things on your phone. And then standard memory management protections are in place. We don't need to go into great detail. These are things that we see on common OSs, but these are things to make memory bug attacks more difficult, things like ASLR, ProPolice. But we don't need to go into great detail, but they are available and do help. And then there are user and application level permissions that we'll discuss in detail on another slide. So one of the things that's nice about Android is applications must explicitly share resources and data. So the idea is that if I need to gain access to some core element of the kernel or core service that the kernel provides, I actually need to ask for that permission. And that application runs in the sandbox we were kind of discussing, which has its own unique UID. So if everybody here has played around on a Unix console or maybe come from a Linux or sysadmin background, right? Every sandbox runs with its own unique user identifier. And a UID only has permissions to things within that sandbox, except for things that are granted to it. And the sandbox runs at a native OS level, so I just wanted to clear up here, in case there's any Java developers here. We're not talking about Java virtual sandboxing or anything like that. This isn't done at the code level. This is actually done at the operating system level. So just a little bit of clarification on that. Any questions so far? Okay. Let's take a look at the screen we're all probably pretty familiar with seeing, right? Applications must explicitly request permissions to access data and services and all that good stuff. So, here's an application that's asking us for our personal information, network communication, accounts, storage, system tools. So, this is kind of a cool, interesting feature, right? We would hope that a user would actually read this stuff. When I watch like my mom or somebody install or my sister install an app, I don't think I've ever probably read any of this. But we hope that, right, the idea is that users will actually read and take into consideration what an application is requesting.
And you can't decline those permissions.
And you can't decline those permissions as well. So if you do say, no, I don't accept this, the application doesn't install.
Although what I did mention about this before with mobile device management, the mobile device management solution can deny some of those permissions, although it could crash the application.
Yeah, and as you can kind of see if we step back here, I know it's a little bit hard to read, but like these are pretty explicit permissions. Things like reading contact data, writing contact data, modifying USB storage contents, write subscribed feeds. I mean, there's quite a bit of permissions that we can have our application specifically ask for. One of the areas, and I've kind of touched on this, it can be problematic. Some of the permissions are grouped together. Like I might see this, it says my accounts, and not actually read through that, but that's my Google Mail, any account that uses authentication credentials of an account. So that could potentially mean any account on my phone. So there's a little bit of a gray area here where potentially Android's trying to group these permissions together, maybe make it easier to read. But I might end up that might actually make it more difficult for me to understand really what's going on under the hood. And then as I kind of mentioned, at least with regards to my sister, users may get desensitized for the permission check and just click accept. I mean, oftentimes if you really want to install an application, you don't really care what it's asking you to do, you're just going to click OK. And that can be problematic. So, there's only a handful of Android devices that, including the Nexus series, that kind of come out of the box with the ability to root the devices. But in general, the rooting process is going to be done by the end user, the attacker. One of the issues that we see with rooting is, unless you're the person that's developing the root exploit, you have to put your trust into somebody else. So there's that possibility that maybe the way you're rooting your phone is actually installing a backdoor or doing something bad. So there is a little bit of a risk with that. Fortunately, there's a pretty active community for rooting devices, and so some of this stuff's pretty well vetted, but at some point you're going to make a leap of faith and trust that this code is okay. However, if you do root a device, users now gain access to the /system directory. On Android, /system is pretty much where everything lives that's interesting. This includes configuration files, network settings, all sorts of good stuff. So the minute I get access to the system, pretty excited, I can now start walking around the file system and making changes to help attack applications. So once I'm root, I kind of can remove that concept of the sandbox and think, well, I can step into any of these application directories and I can look at what's going on. So this really presents, if when John and I are doing mobile application assessments and we're looking at stuff, one of the first things we want to do is be on a device that's rooted, because it really widens up our ability to attack the application and infrastructure that's supporting it. Okay. So iOS, a little bit different of a permission model. It does include the concept of sandboxing. On iOS 5, there wasn't really a concept of explicit permissions. Actually, any application you installed had equal access to all the iOS device resources, right? So we could see that as being kind of problematic. So in iOS 6, they said, hey, we're going to get a little bit more granular. They now ask you, when you're installing an app, if the app can access your contacts, if it can access your email, that kind of thing. And I think what iOS's idea was with regards to security in conjunction or in comparison to Android was the security is really assumed by their application review process. So Apple has when you're a developer and you're writing an application for Apple Store, it goes through kind of a secure code review. They make sure to check that your application does what it states to do. They check it for low-level memory vulnerabilities and all sorts of stuff. And the idea is that that process circumvents the need, at least I think their design thought was, it circumvents the need to have all these explicit permissions. Hey, we're already going through and we're looking at this stuff. I think that's a pretty good idea, except as you guys have probably seen, there's been plenty of malicious apps in the iOS App Store, so things do get by the auditors that are looking at this stuff. And so I think the inclusion of more granular permissions was probably a pretty good design decision for Apple. And so some other additional security features with iOS, keychain services. So this is pretty nice. It provides an easy way for developers to securely store keys, username, passwords, private, public key information, that kind of stuff. It provides a really well-defined, clear interface for interacting with that. And when we look at applications, we hope that credentials and any sort of information is stored in the keychain. When it's not, it's often done insecurely, and it can be problematic from a security perspective. But they do provide an easy way to interact with that. Similar to Android, they provide cryptographic functions for securing for application developers. So the kind of stuff you'd expect to see. They also provide secure file storage using File Vault or iOS file protection, and the concept of code signing, which is kind of a big deal for protecting against me potentially pulling off an app, modifying it, and throwing it back on a device. The idea is that I sign my application, it's installed, an attacker pulls that binary off, disassembles it, does some stuff, recompiles it. Now that signature is not going to match, and I'm not going to be able to run that application. So there are some unique functions to iOS that make it harder from an attacker's perspective to really get down and smash this stuff. So we're going to now step into some of the attacks that John and I use on engagements, as well as the stuff that's being used in the wild by attackers. Do you guys have any questions so far? Okay. Hopefully you guys can read this. When we think about applications, I think it's important to break down kind of the trust boundaries here, right? So we have our application, and we have, on this side right here, we have potentially untrusted data and services, right? We hope that our app checks the validity and reads the data safely, right? So is this information I'm getting, is this the information I should be getting? Is it properly sanitized? Does it present any risk to me? And I also want to ensure to authenticate the recipient and use a secure channel, right? Is this person who they say they are, and are we communicating over a secure channel, right? And so there's this boundary of trust right here. And then we have our trusted data. Now this could be something like local information, maybe our database that it can contain some our keys or some sort of sensitive information, right? So there is a boundary here that we often try to breach when we're looking at these applications. And this is kind of the overall flow that I use when looking at mobile applications. The first thing I want to do is root the device, because I'm going to get all these extra functions and abilities, and that's what an attacker would do in the real world, right? And then the next thing, and we'll actually walk through an example of what this looks like, is attacking the application backend services. So it's really great if I can attack your mobile app, but if I can attack the server that's, that 750,000 applications are talking to and compromise that, that's much more, higher payoff for me. I could potentially do a lot more damage owning the backend server than I could just the client, right? So we'll talk about how we actually intercept the secure traffic and attack those backend services. Another thing that we look at often is local file storage, like the database. Is there sensitive information being stored locally, and is it encrypted or not? And oftentimes we'll actually see applications that are storing personal information, credit card information, sometimes even health information in a database unencrypted, which would put you in violation of HIPAA, for example, right? We could also attack XML processors. Let's kind of skip over that one. Look for debugging log information. So sometimes developers may leave on some debug stuff and not think that anybody's going to ever look at the directory where the application lives. Oftentimes I'll come across log files that contain PII, passwords. I've seen credit card numbers in log files. So, and we also examine plist files for sensitive information and permissions. So, similar to log files, but plist files can be used for multiple reasons on iOS, and sometimes we'll actually see sensitive information in these files. And so these are things that developers need to be wary of when when writing applications. So this kind of ties in attacking IPC endpoints. I'll go back a slide. This kind of ties into the local. Am I in the right thing? Here we go. It ties into local file storage here. So one way that we might think about that local file storage and being kind of interested if it's unencrypted, potentially, let's say that application provides an IPC, as we kind of talked a little bit earlier, it provides some channel to allow other applications to query it for whatever reason. So maybe I have a contact management application on my phone, and I allow other applications to query it. Well, what if I was able to, exploit that query and retrieve information out of your database? And this is things that we kind of look at. Well, if I can do that, maybe I could write an application and mask it as a game or something like that. And every time you install it on your phone, I look for that contact application and I try to steal those contacts. So we often try to attack these process endpoints and see what can we do with them as if we were a malicious application. Another attack that we frequently see is disassembling and decompiling applications. And this is for a multitude of reasons. It helps us identify security vulnerabilities, look for sensitive information in the application source code. As John mentioned earlier, an attacker was able to pull out a private key and start signing code with that key as that organization, that's a pretty serious vulnerability. We could also look for low-level memory application vulnerabilities, things like buffer overflows, integer bugs, that kind of stuff. A little bit more difficult because, as we mentioned earlier, there are some memory protections in place, but something that we still see attackers doing. And then looking for snapshot files. So this is the idea of when you, at least on iOS 5, when you close an application, your phone takes a picture stored in your app directory. Well, if I get access, if that included maybe a login screen and the password wasn't blocked out, and you turned your phone off, it might take a picture of the screen. Oh, I've actually seen that. And then you can pull the picture off the application directory, and you can see somebody typing in their password or something like that.
The disassembly part is interesting because these both platforms, the applications are written in languages that are relatively easy to disassemble.
Right.
Java in particular has some really good disassemblers. And the files are easily accessible. A package is not bundled into a binary application. It's sitting there and executing with all the Java files that you need. So an attacker who can gain access to that application, which essentially all they need to be able to do is to download the application, can then run it through several known decompilation tools and then read the code, maybe not in exactly the same format that the developer wrote it, but in a readable enough format to understand how the application works at a core level.
And if we flip back to Android and you build a default Android app with no flags for obfuscation, which we can touch on a little bit later, you can actually pull that application off, run dex to jar, end up with a Java jar file, run it through JDD compiler, and end up with full source code. It's not even bytecode or anything. You can literally, you got the class files and everything, and that's maybe 2 minutes of work. And so, an interesting exercise would be go to Android App Store, pull down the top 100 apps, and see how many of them aren't obfuscated. I'd be surprised if they all were. And that's unlike .NET programming language, where it's, if you want to obfuscate your code, you just click one button and it says .obfuscate. So one thing I would expect to see in future releases of the SDKs is really easy, trivial ways to obfuscate the code, because I think that'll make it a lot more difficult for us. It's still possible, but more difficult for us to actually be able to read through and figure out what's going on. So we're going to kind of walk through an application attack scenario, and this is pretty much the first step I do after I have a device and have got an application to look at from an assessment perspective. The first thing I want to do is I'm going to use a web application proxy. Okay, so I'm going to look at a way for me to intercept traffic between the web application and the back-end services that a web application may talk to. Now, as a developer, you're probably thinking, well, I want to have this over SSL, right? I don't want this kind of thing happening. So what we end up doing is we actually tell the phone to trust our root level certificate for our proxy, right? So the idea is that I have my application on my phone, I have my proxy, and I have the web server. And what I'm actually doing with that proxy is I'm telling the phone, trust this proxy. And any time I go to Google over SSL, trust Port Swigger is actually Google. And you'll see Port Swigger is the name of the certificate that I'm using here. And so what ends up happening is the application goes, all right, well, I'm going to make my request to Google. And if I don't have my root certificate installed, it goes, oh, can't verify the server identity, right? However, if I install the root certificate correctly, I'm going to go to google.com. My phone's not going to know any different. It trusts Port Swigger. Port Swigger can tell me any sites over SSL, and my application's going to feel comfortable with it. So that's the kind of the first step that we do. We copy the certificate to the phone, and I don't know why that slide's there. Once that root certificate is installed, the proxy automatically generates self-signed certificates for each web server or service request. So every time I'm on my web browser now and I make a request to google.com, yahoo.com, chase.com over SSL, I don't get this error anymore. Can't verify server identity. The phone just trusts what's going on, okay? So now I'm in a position to read all of this traffic.
And this is no different from enterprise technologies like Blue Coats or other SSL interception. So
it's the same concept. We're just applying it on the mobile platform here. So since our proxy certificate is trusted, the application will think every SSL certificate presented for each domain is valid. And now what we do is we configure the phone's network to proxy internet traffic through the web application proxy. So all I basically do on iOS, I go to my network tab and I say, I want you to proxy all my web traffic through my other proxy. On Android ICS 4, it's a little bit more complicated, but it's still doable. We don't have to go into the details. It's easier on iOS.
It's easier on Android.
There's a little bit more hoops you gotta jump through on Android, but it's still doable.
Yeah.
Now what the attacker is going to do, I'm going to launch the application and begin to perform functions. Meanwhile, all the encrypted SSL traffic to and from the mobile application backend web service can now be intercepted and modified, right? So I'm in a pretty powerful position here. All that stuff that was secured is now available for me to interact with, intercept, modify, and so I control now, the CI and the A model, right? Confidentiality and integrity. I can mess with both of those things to the full extent. And so here's an example of me logging in the Chase, right? So you see my web application login request right here, auth login, and we see stuff like my password, refer header, what type of request it is. All these information that's kind of under the hood that we wouldn't be able to see. And now I can start fuzzing or doing other sorts of attacks to attack not the mobile application itself, but the back-end services that are associated with that application. So this really gives us, some pretty powerful, we just took what was just a mobile application and now we've opened up our attack vector much more wide, right? Now we have the ability to target the back-end web service as well as client-side vulnerabilities to trigger interaction with web services. And so this isn't much different than how we do web application assessments. Actually, I use pretty much the same exact approach when I'm looking at a web application. At this point, it actually turns more into me looking at the back-end services. But I think one of the things that's a little bit kind of a common mistake with developers who are implementing these technologies is not realizing that an attacker may be able to intercept that traffic and interact directly with those back-end web services. Anybody have any questions about how that attack looks? Okay. Oh, and I wanted to touch on one slide here that was out of order. So one of the things I think was a little interesting is that many of these security features and even MDM don't address a lot of these attacks. If we think about the attacks I was discussing, MDM might help with maybe the encrypting the local data store, and maybe the code signing makes it so I can't modify the binary, but it's really not going to help me if I'm
protect you from installing a root certificate.
It's not going to really, and it might be able to protect me from installing a root certificate, but maybe I'm going to potentially still take advantage of insecure coding practices, and I'm going to try to work within that MDM and see what can I still do with the application. Obviously, there's a lot of entry points. We can enter in at the client of the mobile app. We can enter in at the services the application communicates with. We can interact with the database. So there's a lot of areas to look at. And we also have to take into consideration that the back-end services probably operate in a different trust model. Is the trust model that's on my mobile phone and my mobile client different than the back-end services? Probably. And I think oftentimes, those services, might operate in a trust model that maybe isn't quite as locked down. And we tend to see that when we're looking at these mobile apps, we often find more security vulnerabilities in the back-end services than we do in the mobile applications themselves. Okay.
And I think sort of maybe some of the root of that could be just the fact that, as Scott mentioned earlier, if you're developing on Android and iOS, you're developing on a new platform that has a lot of security features built into it. But if you're developing a web service, you could be doing it in anything. You could be doing it in ASP, you could be doing it in PHP. There's so many different ways you could be developing a web service. There's a lot of opportunities to make security-related mistakes, whereas you can obviously make security mistakes when developing applications that run natively on the phone, but you have less leeway because the SDKs are designed to some extent with security in mind.
Right. Okay, any questions?
Sure. So when thinking about building secure mobile applications, and I guess I'll take this. You can think about this from a few different perspectives. But the biggest thing that you want to think about first is encrypting your local data that's stored on the phone, because, as we mentioned before, not all applications have local storage of data, but most do to some extent. And you must first off assume that an attacker is going to be able to access that data. So if I'm accessing an encrypted blob of data, it is much less useful to an attacker than if I'm storing all my data in the clear. And in particular, if you're using iOS, use the keychain, because the keychain is a well-vetted piece of technology. It exists pretty much the same between iOS and OS X, and it's great. I wish it existed on Windows.
And another thing to take into consideration is when you are storing local information into caches, to kind of just consider what may be considered sensitive or not. Oftentimes we see stuff that's stored in a clear and stuff that's stored encrypted, and some of the times the stuff that's stored in a clear might not seem like it's sensitive information, but for an attacker it could be really interesting. And I'm trying to think of an example here, something like maybe you're storing really verbose information about some libraries in the application, or there's certain things that might give an attacker a little bit more insight in either how the application works or how the backend web service works, or things like that I might use to build to help construct some of my attacks or focus on particular areas that might be weak in your product. So it's kind of important to kind of threat model, what's coming in and out of my application and what really is sensitive.
Yeah, so going off on that, so you shouldn't be storing secrets, passwords, or keys if possible. Again, we have to assume an attacker can decompile and see your code. So if it's not required, or if there's an alternative way you can do authentication in particular, do it. Don't hard code passwords into your applications. That's terrible. Request and use minimal permissions. So this is something that is also, again, both a function that's good for security, but also sort of a function that's bad from a developer education perspective, is that these are both relatively new platforms. The most experienced iOS developer has only been doing it for 6 years. So developers are still learning what permissions are necessary for different applications. And granted, the software platforms haven't made it easy and clear necessarily all the time, but sometimes developers are using sample code that they're using as a starting point that includes way more permissions than they need. And in fact, sort of the lower level, the less permissions that you actually need to do your applications, the better, especially from the security perspective and the eyes of your users. It's really weird that Angry Birds asks me to access my contact database, but Angry Birds is really popular. So don't do it if you don't need to. One thing that we didn't talk about specifically when talking about application permissions, but is sort of a worthy sidebar, is that a lot of the reasons why these permissions are being requested is due to mobile ad networks. That's a big source of revenue, particularly something that you see on Android. Google owns a mobile ad network. Android collects a lot of data that's used for Google to sell advertising better, because that's how they actually make money, not by providing search queries. a lot of the things that you're seeing, if you see like an application you wouldn't think, like again, Angry Birds requesting your general location, is because the ad network associated with that is requesting the location. So they want to be able to provide targeted ads for you, knowing that you're in Chicago versus in Los Angeles. So there's not a perfect answer, because to some extent the platforms are sort of incentivized to work for advertisements, but if you're building an enterprise-focused application, there's no reason why you should be requesting permissions that you don't need them. For public applications, it can go both ways. I'm kind of in favor of requesting minimal permissions as well, but you can see the business case for it. And then when doing development, examine your application's IPC calls and make sure that they're being done correctly. Don't expose interfaces that you don't want exposed to other applications.
I shouldn't be able to reset a password for one app from another app. And yes, I've seen this. So these are things that can happen. Maybe a developer, just for ease of use, left in some IPC calls to make it easier when they're doing development, and then left that stuff in when they release to production. That can be pretty dangerous. If I can create a little game that every time you install my game, it looks for your banking app and resets your password on your account, for example. I think that probably pretty unlikely, that particular sort of IPC call, but there might be other IPC calls that an malicious application could kind of look for on your phone and try to make those requests.
Mm-hmm. So, going along with that, so you want to ensure that before you ship your application, make sure that it's production ready. So you don't want to include, logging that's unnecessary, backdoors that you included only for debugging. Like Scott said, IPCs that you're only using while you're developing, unencrypted storage. A lot of times developers cut corners in the development process when they're making these, just because, building an encrypted database when you're trying to figure out why your data isn't writing makes it really hard to debug. But before you, this kind of gets into an overall SDLC process that we're not here to talk about, but before you move your code to production that you're going to deliver to end users, you want to make sure that all of the things that you've done for ease of development have been disabled and you're shipping secure code. Implement encrypted connections for everything. Yes, we can man in the middle and read them, but that doesn't mean you shouldn't do it, because if I'm at Starbucks sniffing the wireless of everybody using it, and you're using your iPhone on Starbucks sending your Chase traffic, that's potentially not an encrypted connection. Maybe Chase is a bad example, but
Maybe another, up until a few years ago, Facebook's mobile app wasn't over SSL.
Yeah. So I'm sure you guys heard about this thing a couple years ago called Firesheep, which was a tool that somebody wrote to sniff wireless unencrypted traffic and make it really easy to take advantage of user sessions that were sent over unencrypted sessions.
You could basically sit in a coffee shop, turn the application on, and a little frame would pop up in your browser, and it'd say, oh, I just compromised John Doe's session for Facebook, I compromised John Doe's session for MySpace. Double click, and then you're that person on the website.
Yeah, so
very, very easy.
Those attacks still exist. Firesheep isn't supported anymore, but that doesn't mean that it's not still something that exists. And this is another thing, assume that somebody is going to do a security assessment of it. So yes, people pay companies like NeoHapsys to do security assessments of their software, but there's a lot of hobbyists out there in the security world who do this stuff for fun, or just for laughs, or just because they're trying to get themselves a job. So assume that somebody's going to be looking at it. It's a lot easier to disassemble, like we mentioned, a mobile application than it is to disassemble a binary application that's living on your desktop. And also perform security assessments of your mobile applications using third parties or using an internal team. Just assuming that it's good to go just because it works does not necessarily mean it's implemented securely.
Yeah, even following all these steps that we've kind of outlined here, when it comes to the assessment phase, something could still be off. And so, I definitely think it's a crucial part for the application development lifecycle, especially for mobile apps, is to at some point circle back and actually do what the attackers are probably going to do. Because you'd be surprised how often we see a lot of these best practices in place, and then there's just one mistake which completely compromises the rest of the controls that the developer spent so much time doing.
The earlier you can implement this in the process, the better. The developers are not necessarily always the best candidates for who should be auditing their code, because it's difficult to maintain the separation of what's yours versus if it's being done correctly. But it's a function that should be implemented, and we find it very valuable amongst our clients who do that.
Yep.
So, summarizing things. I guess mobile devices presented a unique set of security concerns. Bring your own desktop is something new. There's all of these potentials for data loss. Mobile applications have a lot of the same risks as traditional applications. They're not as different as they may seem. And we want to take a hybrid and layered approach to handling mobile security. Not much different from how you handle desktops, but you just need to be aware of the different challenges that they present.
Right.
And
That's pretty much it.
here's our big reference page.
So does anybody have any questions?
You're talking about the secure application security code review. Typically, pushback might be time or resources. Typically, what is that, would you say, for basic mobile app? How should they get that in front of the plan?
That's a really good question. I'll repeat it because I want everyone to hear it. So Matt was asking, a lot of times when we suggest to do this, the pushback is we don't have budget for it or we don't have time for it. And what is the average time that assessment like this takes? You want to answer?
Sure. So, we try to work this in before, when the application is pretty well developed. We're doing an assessment right now on a web app that's actively in development, and it's been really difficult because it's not me, Tom. He's like looking at something in the app, and then like 2 days later, they're like, "Oh, we have a new build." Pull it, feature's gone, just removed. Totally new features there, and so, from a value perspective, in the software development lifecycle, when your application's made it to QA and is production ready, is when we typically recommend actually doing these assessments. Or when there's a code freeze is even better from a certain perspective, because we want to make sure we have as much coverage as possible. With a mobile application, something that's not overly complex, but maybe provides some functions, has pretty decent sized application, we typically allocate between 7 to 10 days to do the assessment with reporting, recommendation, remediation. So, depending on your developer's turnaround times for identifying vulnerabilities, you want to make sure that you do this assessment, before launch date with enough time to remediate any critical, very high and high risk findings. Typically, when we're recommending this to an organization that's about to launch, their go-to strategy with the application, we don't want to see anything below a medium risk in the application, because those high and very high risks could provide direct access to customer reputation, financial loss, all those things we were kind of discussing earlier. So it's kind of important to do it at the right time. I mean, we have run into circumstances where the client's like, we need to do this application now. We're launching in 2 weeks. We come in and we do the assessment. We give them the report, and they launch the application without remediating the vulnerabilities. And that's a serious risk for the organization, because all it takes is one hacker over a summer break, right, to look at that application, find that vulnerability, and cause the triage that whole chain of risks for your organization. So,
and I think, especially if you have an internal security team or an internal application security team, I think an effective approach is to get that team involved at the design phase, so you can sort of mitigate these risks before they come to a head. One of the clients I'm working with, we try and do design reviews sort of in the architecture phase, and then we talk out the architecture before the application even goes into final development or it has all their requirements defined. So we do that. Then they go ahead and do the development. Then we circle back in a month or so once the feature's been implemented or once the application is ready to go, and then we're testing the application that we helped design, essentially.
And often in those times, if the developer took our recommendations correctly, those vulnerabilities don't we tend to not find a whole lot, and that's good. That lets us know that developers are using sound security practices when they're working on their code.
Right. Any other questions?
Yes.
How does a new out-of-the-box phone compare to a new out-of-the-box desktop as far as security goes? Is it Wild West out there, and it's
I can handle it.
it's a wide
So the question was, is there a big difference when you purchase a new phone out of the box versus a laptop out of the box? And so there are some parallels and there's some differences. One of the parallels is bloatware, right? So when you buy a Dell or an HP box, you end up with this, Windows, maybe it's a Windows 7 or Windows 8 host, but associated with it is all these other applications that HP's written or third parties have written. So now you have all the risks associated with those applications. The same thing happens on your phone. When I bought an Android phone from Sprint, I got home and there's like 8 or 9 Sprint applications on it. All have their own permissions, can all do their own stuff. And so you kind of run into that parallel that's between the two platforms. But the other biggest difference between mobile and desktop is, when I purchase my desktop out of the box or my laptop and I get home and I unplug it, I'm actually an administrator on that device. I can immediately start doing things. I can totally wreck my phone. I can remove stuff. I can set up
the machine.
You kind of run the whole machine. On the phone, oftentimes when I go and buy, my device isn't rooted. I'm just a user. I can install apps and stuff, but I can't access the nitty-gritty of the file system. And so by default, at least out of the gate, the phones actually have a tighter security model than desktops and laptops do.
I think, since Vista, Windows has tried to implement the concept. And this is, of course, different in an enterprise if you have a whole Active Directory that's limiting who's an administrator. But just on a solo device, you have, Vista and Forward with Windows has attempted to, provide the concept of having user account control. So if an application is requesting system-level features that need additional elevations, it does the big flashy screen saying, "Bong! Do you want to grant this application permission?" Usually people say yes, or in the case of since Windows 7, they actually disabled the big bonkiness of it. But so they've tried to harden it up a little bit, but I guess out of the box, if installing from scratch, you can be administrator on the device. In an enterprise, if you're implementing a whole Active Directory, there's a lot of controls you can do. And if you're, building out an image before you give it to an employee, you can harden it far more than you could harden a phone if you're just buying a phone straight from Verizon or whatever.
Absolutely, but yeah, just from an end user perspective, I think that it's pretty safe assumption that you're most likely going to have a little bit more of a limitation from a security perspective on your mobile device than on the laptop.
But I think what MDM is allowing is sort of the same level of hardening that you can do when doing a system build in an enterprise.
Yeah.
So
enforcing all the Active Directory policies and permissions are very
Exactly.
similar to what you might see in an MDM solution.
The first thing you do would be you provision it, and then it says, I'm going to disable camera, I'm going to disable GPS, I'm only going to let you use wireless on these 2 SSIDs, and lock the phone down from that perspective. It's a little more complicated. It's not something straight out of the box, but implementing those type of enterprise controls for desktops is also more complicated. So it's an engineering effort, I think, that is well spent. So.
Have the root certificate.
Mhm.
You guys seem good. That type of thing.
So MDM can disable the installation of
believe
root
so.
certificates. Yeah.
Yeah.
So MDM can actually disable the installation of root certificates. Highly suggested. It's like the first thing that I always try to do. From an application design perspective,
I mean, not really, because you're talking 2 different layers. So
Yeah,
that's
'cause
at the transport layer.
the issue that we're running into is that we're actually, that's occurring at the transport layer. So the application has really once we tell the OS and the kernel level to trust that root certificate, there isn't really a way can we think of a way that would be able to detect that?
So yes, I think that there's, and I'm not an SSL expert, but I think that there's a way you could configure SSL services to look for evidence of tampering.
Well,
You
it wouldn't,
could do-
but it wouldn't technically be tampered though, right? Because it would be a trusted root certificate.
But
Right.
your listener, the server listener, would reject requests coming from a client that looks like it's been man in the middle.
Yeah, so actually client certificates would be a way to do it.
Right.
So one way that you could do the communication security would be to use client certificates, right? So the idea that I have a certificate that's installed with my application, and as long as that certificate's presented to the server, that communication can occur securely.
Right.
So I would need to gain access to so I would need to gain access to that certificate to be able to intercept that SSL traffic.
Right. So that's how you do it.
Actually, a good question. Have you seen any client certificate mobile apps? So
There are actually. So I just read an article discussing a few of them. I think actually Twitter may actually be one of them.
So that's a pretty interesting approach. That makes it pretty much way harder for us to do the SSL
Right.
man in the middling then.
It's
I
always
see it on
possible-
desktop applications a little bit. Like I looked at a trading application that used client certificates, but I haven't come across it personally in mobile. But
It's possible, but it's a lot more overhead,
Overhead on
you
the
know,
development.
because you have to generate a new certificate for each device and that sort of thing. So, but it's possible.
Any other questions? Oh, any questions on for the remote people who dialed in?
No questions from Madison.
Okay.
No questions from Madison.
All right.
All right. Well, I guess thank you guys for your time. I hope you learned something and enjoyed it. We'll be out having some water if you want.
Yep.
Chat with us
Thank you very
offline.
much.
So